these others here, if you want a better graph than what I'm doing, you can absolutely go there. So number one is a growth function. I'll talk about why in a moment. It's related to number three, which is not a growth function. It's a decay function. What is the main difference between one and three? What do you see?
Well, 3's a fraction and in parentheses.
Good. And number one?
I mean, it's just 2. I mean,
Good. That's it. It's as simple as that. So here's what's going on. Y equals a to the x, okay? If 0 less than a less than 1, so if it's a fraction, but more specifically a fraction between 0 and 1, this is always a decay function. Okay? If a is greater than 1, which is the case in the first one, it is considered a growth function. Okay, and it will resemble the two graphs that we have shown there. So I know you don't have to do it, but if I were to ask you to do number two, based on this, y equals 4 to the x, is this growth or decay?
growth.
It's growth. And I'll just give you another one here. Let's say I give you y equals 3 over 2 to the x. Is this growth or decay? Is this number in parentheses between 0 and 1, or is it bigger than 1?
Would it be growth?
It is growth, yes. So sometimes they're deceptive, like they make it appear that it's not, but it really is. So that's, if you want to, like, what's the main takeaway from the first 5 minutes of our lesson today? It's that right there. Okay. Now, unfortunately, it gets more confusing, which that's what math does. So let's look at number 5 here. And if I'm going too fast where you don't have enough time to get these down, please let me know. You'll also get the notes at the end as well. Let's take a look at number 5 here. So if you could imagine just 3 to the x, what is that, growth or decay?
Growth.
So it looks like that. This negative in front is a reflection over the x-axis. So it takes this graph that you just said is growth, and it flips it like that.
Yeah.
Now I know you can get that from Desmos. I want you to know why it does that though. It is growth, but then this flips it. Any questions on that?
No.
Okay. All right, so number 7 is very similar. Could you, on your paper, based on what we've just done, draw the graph of this one? I would recommend breaking it apart into this first part and then using the same transformation on this in front. I'm not going to ask you to send it to me. I'd just like you to try and sketch this on your own, if you don't mind. Rough sketch, nothing too exciting. Let me know when you've got something down.
All right.
All right, so again, growth function, this would be 2 to the x. That negative flips it over the x-axis. All right. So we've covered a couple of transformations now, and before we get back to your assignment, I am going to go to Desmos. I think it's a great tool. I wish you guys had access to it all the time, in the classroom. Some do, some don't. But there's a bit more here, okay? And like we just talked about, if I put a negative in front, it flips, going from up to down here, okay? But that's not why I wanted to show this to you. I want you to see what happens when we add a number to the outside, okay? So notice this number is not part of the exponent, it's just like plus, okay? So if I make k bigger, what is happening to the graph?
Just moving up.
That's right. And if I make it, let me get it back to 0. When it's 0, it's there. But if I go the other way, what happens to the graph? It becomes negative.
Mhm.
What do you see?
Just moving down.
Right. So you can see it moves up and it moves down. All right. So that's very important to remember. Now, let's look at another one here. I don't want a slider. I want you to go away, graph. Okay. All right. So let's look at another one here. Just give me a moment here to get this set up. All right. Let me make, this one's a little bit harder to see. So I have to actually graph some points here. So imagine I got to plot some points. Give me just a moment here to get this going. Okay. All right. Why isn't that labeled? All right. So here's what I've done. I've graphed 2 to the x, that's in red, and then 2 parentheses x minus 1 in green. What do you notice about this point, the black point and the red point? How are they related to one another?
I mean, their y is the same, but the green line is just moved over to the right one more.
Exactly. Well said. That's really well said here. I'm just going to clean up some colors here because I think it's distracting the way it is. So let me try this one, turn that into green. Okay. And then watch this here. Put a K there. We're going to add a slider for K. And all right. So now watch this here. What's happening to that green? What do you see there?
X, it's just moving on the x-axis left and right.
Left and right. And notice that's from the exponent up here. All right. Now the awkwardness of this is like, let's say I make K 5, X minus 5, it moves it right 5. If K is negative 5, it moves left 5 because it's X minus a minus 5. Now it's awkward. It's weird. It doesn't make sense, but these are the rules. These are the things that we have to go by. All right. So I'm going to summarize this. Do you have any questions or do you want to see anything else on this before we go back to the other screen?
No.
Okay. This relates to the next set of problems here. So here are the transformations that we have talked about thus far. All right. If it's y equals negative a to the x, this is a reflection over the x-axis. This is like your cliff notes, okay? If it's y equals a to the x plus k, okay, so basically just a number off to the right here, this means k up or k down. That was the first one we did in the Desmos screen. Then we did y equals a to the x minus k, and it has to be that way. I have to put a minus there. And it's either k right or k left. So this kind of summarizes everything we've done today. There is kind of this overarching branch of, is it growth or is it decay? We will get to that as well. We'll kind of introduce that as well. So we're going to do 11 first. Okay. Do you have Desmos open on your computer by chance?
Yeah, I can open it. Yeah.
Okay. Well, here's what I'd like you to do. I'd like you to first like make a guess to yourself. Say, I think that this thing over here does whatever you think it does. And then I want you to verify it graphically. If you can quickly do that. So, take a minute here, see if you can give me the, tell me what it does, and then verify that graphically, please.
Like, you want me to write down what I think it's gonna look like, or?
Yeah, you were just, we're just making a guess. Like, is this up, down, left, or right, basically? Or you can tell me. I'm okay with that as well.
I mean, I think it looks gonna look like it's probably just gonna look similar to, well,
Which one does it remind you of 1, 2, or 3 here?
I mean, definitely 2.
It's 2. It is 2. So it's either up or down. Okay. And that's what I'm trying to get you to tell me now is do you think
I
it's
mean, I
3 up?
think it's gonna be going down honestly because it's
Okay.
minus, but
All right. So do you have Decimos open? Can you quickly graph this?
yeah.
Now, what you also want to do is graph y equals 2 to the x, hit enter, and then 2 to the x minus 3. And I'm going to do the same thing. I just want you to do one on your own. See if it makes sense. See if there's anything that's unclear about this.
Okay. I put it in. Looks like it's just going up.
All right. Let me new share this with you. Does your graph look something like this? Maybe different colors?
Yeah, looks like the green line.
Good. I agree. It is down 3. All right. Okay, so let's go on to your next problem here. If I can get back to my screen, there it is. All right, so your next problem on your page is number, I went forward when I think it was number 9.
I put the tab on the wrong page, Tristan.
On what?
There's a blue tab on the next number page.
Yeah.
Okay, so notice this time the x is in the +1 is in the exponent.
Yeah.
So does this look like 1, 2, or 3 now? Let me see if I can squeeze it all in there. I mean, it's either 2 or 3.
3.
3. So it's either right or left. And this is the one that's always opposite of what you might think intuitively. Okay. So intuitively you might think, oh, it's 1 in a certain direction, but it's actually the opposite. What do you think here? What's your guess?
I don't really know because that number seems that like it never makes sense.
So
what it
1
looks
left
like.
or 1 right. So
One right, I guess.
so 1 right is kind of that, like that's what it looks like, but it actually is 1 left.
Yeah.
So you have to remember that rule. Did you know do you know how street numbers are made? Like
Kinda.
one side's odd, one side's even.
Yeah.
It's kind of like that. Like, I don't know why it is. That's just the way it is. We got to go with
Yeah.
it. We just, okay. Yeah. So if it's, and the problem is the -3 here on the outside, it literally means 3 down. That makes sense to us. When it's inside parentheses, it is not.
Okay.
All right. So really quickly here, because I know there's other stuff you want to work on today. For exponential functions, there's this discussion of domain and range. Okay, so the domain is always all real numbers. Everything. There's no exceptions. Range, though, this is where there's more effort to be done. Okay, and there's a couple of possibilities. It's either -infinity to what is called the horizontal asymptote, or it's the horizontal asymptote to positive infinity. And this is based on a couple of things that we're going to look at now. All right, so I'm gonna graph the function. I'm going to graph 7, 9, 11 again, snip them in, and we're going to talk about the range. All right, so let me do that here real quick. 7 is -2 to the x, y equals 0. I'm just going to quickly make this a dashed line. All right, fantastic here. So let me snip this in. All right, so this is for number 7. Okay. The purple line here is the horizontal asymptote. It's the equation is y equals 0. Okay. How do I get that? The original graph is y equals -2 to the x. There's really a +0 off to the right that's not written. That's what the horizontal asymptote is. It's whatever number is kind of written off to the right here.
Mm,
Now the range I mentioned is it's either -infinity to the horizontal asymptote, or it's the horizontal asymptote to positive infinity. The range is always bottom to top, or if you prefer, min to max. I don't know if either of those phrases like sound better than another, but do you want to tell me which one you think it is? Is it -infinity to, and this problem would be, is it -infinity to 0, or is it 0 to positive infinity? Basically, like how far does this green line go down?
well, it'll keep going down forever.
Right. So which one of these would that be?
Negative infinity.
To 0.
Yeah.
So this the range here, and I know I'm giving you options, but it's really to show you that there's only 2 possibilities. Is that okay?
Uh,
All right. Let's look at number 9. Sorry, it is a little slow here to go back and forth, but probably good to do it this way. All right, so here's number 9. All right, so here we go. This is number 9. Let's go and use red. It's a bad color. All right, y equals 0 is again the horizontal asymptote. And why is that? Because this is 2 to the x plus 1, and there's nothing written off to the right here. It's +0, and that's why y equals 0 is the horizontal asymptote. Whatever is written here is that. So is your range -infinity to 0, or is it 0 to positive infinity? Same question, like what's going on with this green line? Is it going up forever, down forever? What's going on there?
going up forever.
Okay, so which one would it be? Would it be this first one or the second one?
0 to plus infinity.
Good. Only 2 options. All right, and then really quickly, we'll do the last one there, number 11. The graph really helps. Like if you can get your instructor to allow you to graph these using Desmos, you'll be way ahead here. What do you think the horizontal asymptote is in this problem? What is the number that's just to the right of 2 to the x?
-3.
-3. So that is your horizontal asymptote. That's kind of what everything approaches. An asymptote is something that it approaches and gets closer and closer and closer to, but never touches. So let me get that going here. -3, -3. All right. All right, so on the graph here, grab a snip of this again. All right, so here's your graph. This is y equals -3. You can see that that green approaches it. So this time is the range -infinity to -3, or is it -3 to positive infinity? What do you say?
Like the green line.
Yeah. Basically,
-3 plus infinity.
yes, perfect. Very good. All right, any questions on that before we move on to something else?
No.
Okay. All right, so that takes care of assignment 1. Hopefully that's sufficient for what you need to turn that in. We're on to number B here. Ooh, factoring. How do you feel about factoring?
I have no idea.
Okay, good answer. You've definitely not been given very easy problems here. I'm going to move us to 9.2 first. This will probably be better to kind of lead into that, I think, because this factoring does look easier. All right, let me snip in first problem here. We want to gradually, get more difficult here. We don't want to just take big steps there. Okay. All right, so this is actually from the third assignment. I hope that's okay that we're going out of order. I think this will make more sense though.
Which pages is he got? Are you able to see the pages?
Page 389.
Oh, okay. All right.
All right, so 6y over x squared times x over y squared. All right, so whenever you're multiplying, you can always multiply the tops and then you multiply the bottoms. Now there's this preference, and I say it this way because I don't know that it's really a rule. There's a preference that x comes before y. And it's just alphabetical order.
Yeah.
So that's why I put the x before the y in the numerator. Now there is this exponent property, and I'm going to write it off to the side here, that says if you have the same base, okay, x is the base, different exponents, but you're dividing, you subtract the exponents. Have you seen that before?
Yeah, I think so.
Okay, so in your problem, it's really three problems. It's really 6 x to the 1 over x squared, y to the 1 over y squared. This middle one becomes 1 minus 2. What does that become?
X -1.
Okay, so you got x to the -1. How about this next one here with the y's?
It's y to -1.
Good. And you have a 6 out in front here, and these are all multiplying. Is that okay?
Okay.
So kind of a new rule here off to the right is that if you have a negative exponent, you write it as a positive exponent, but it goes down to the bottom. So an example would be, let's say it's x to the -4. This becomes 1 over x to the 4th. How would that change what's here? Well, how would you rewrite x to the -1 based on this down here in the lower right?
I have no idea.
Well, tell me what you see over here in the lower right.
X -y equals 1 over x to the
Okay,
4th.
so that's my
Oh,
fault.
four.
-4. It's a -4. Let me make that even better. Okay. So what changed from -4 to +4?
Just put a 1 over it.
Make it positive, right? It went from being a negative number to a positive number. So the same thing applies here to this x to the -1. So give me the kind of the right side of the equation here. What does this equal, x to the -1? How can we rewrite it down here?
1 over x
To the 1. Good. Yeah, that's correct. And same thing for the y there. What does that become?
1 over y to the 1.
Yes. The 6 can be written as 6 over 1. Any number can be written as being over 1. Is that okay?
Okay.
All right, now we're going to multiply the tops. So 6 times 1, which is 6. The bottom is 1 times x times y, and we'll just write it as xy.
Okay.
Okay. All right. This is stuff that was covered in Algebra 1. You're currently in Algebra 2, is that right?
Yeah.
Okay. So my concern here is like 3 is like doubly difficult as 1. And if some of this was unclear, and we'll go through it together, but I just want you to give me some more feedback. Just say, hey, like I've never seen this before, or I feel totally lost, or whatever it may be.
Okay.
The whole goal here is to rewrite it without negative exponents. You cannot have negative exponents. Okay. All right, so let's look at number 3. I'm sure you got to turn some of this stuff in, so that's why we're going through it, but quite a bit goes into every problem here. All right. 5a cubed b to the 6th over 10a squared b to the 4th times 6a to the 4th over 2b squared. So we're going to first multiply the top, okay? And multiplying the top, we're going to first multiply the 5 and the 6. So that's 30. When you multiply the a cubed and the a to the 4th, there's a rule again. We'll put that off to the side here. When the bases are the same and you're multiplying, you add the exponents. So do you see how the base a is the same as a here, 3 and 4? You're going to add the exponents.
Yeah.
Becomes a to the 7th. There's nothing to go with b, okay? So it just comes along. So again, you multiply the numbers. The letters that are the same, you keep the letter, but then you add the exponent. 3 and 4 to go 7. B doesn't have anything to go with, so it stays there. Will you multiply the bottom for me, please? And tell me what you come up with.
Yeah. Mm,
What do you say?
um, I was trying to figure out how to multiply, mostly just because I'm trying to remember even how to do that.
So
Maybe
let's
this
do it
is
in
fine.
pieces. What's 10 times 2?
20.
20. Okay. Is there anything to go with the a squared? Do you see another a over here on the bottom?
No, it'll stay.
Okay. Do you see anything to go with the b to the 4th? Sorry, I'm trying to get my.
Yeah.
What do you see? B to the 4th times b squared. What does that become?
B to the 8th
You're adding the
or
exponents.
2b or
4 plus 2.
B6.
B6. Good. Yeah. All right. So now we can attack this problem like we did in the previous one. It's really 3 separate problems. It's 30 over 20, a to the 7th over a squared, b to the 6th over b to the 6th. Okay. And the rule is if the bases are the same and you're dividing, you subtract the exponents.
Mm. Okay.
All right. So now do you see bases the same here with A?
Yeah.
Okay. So you're going to subtract the exponents, top minus bottom. Maybe that's easier to remember. Top minus bottom.
So 5, A5.
Good. How about the one on the right here with the B?
Just cancels.
That's right. So anything to the 0 power is 1. It does cancel. 1 means it just goes away. How about 30 over 20? What do you see there?
10.
You can't. Good try. You actually divide these. I can see why that. It's like you do two things in a row the same. And you think the third's just like it. With the numbers, you just do the typical divide. Like the zeros cancel, and you get 3 divided by 2.
Okay.
Any questions on that before we move on to something else?
No.
Okay. All right. Do you play guitar? What's your kind of your music situation?
Yeah, I play guitar.
Oh, nice. I know absolutely nothing about it, but I think it's awesome to play music.
Yeah.
It's always nice to see someone who can do something really well. And have you been playing for a long time or?
Think it's almost been 2 years.
Cool. That's awesome.
Yeah.
All right. So this is number 5, but we're going to do it in pieces. And the reason I didn't go straight to page 386 is because these problems are like they're harder versions of the ones I'm showing you here. So I figured we'd try this. Now what you do is you just start with like one at a time. So we're going to look at just this top left one. And we're going to talk about how to do that. So I'm actually going to clear the screen here, and we're just going to look at factoring, how to factor something like x squared plus 9x plus 18. Okay, so this would have been covered in your Algebra 1 class. It's okay if you don't, but do you remember anything about how to do this? Anything you can tell me?
It's kind of hard because in class, because in Algebra 1, we were being taught the X factor or something like that. But now our new teacher doesn't like the X factor method, and I think it's called like trial and error or something. I don't really know how to do it though.
Okay, good. Yeah, that's what I was looking for. I wanted to know if we were starting from 0 or starting with, using some knowledge. That's okay. All right, so I'm going to write the number 18 off to the right here. And I'm going to write 1 and 18, 2 and 9, 3 and 6. If I take 1 and multiply it by 18, do I get back to 18?
Yeah.
How about 2 and 9? Does that also get you back to 18?
Yeah.
How about 3 and 6?
Yeah.
So all of these multiply to 18. Now I'm going to add them. 1 plus 18 is 19. 2 plus 9 is 11. 3 plus 6 is 9. Okay, do any of these add to 9?
Yeah.
So here's the 9. And here's the 18. All right. So the rule here is that you're looking for two numbers that multiply, that's spelled poorly, multiply to 18 and add to 9. And we have found them. It's 3 and 6. Agree with that? 3 and 6?
Yeah.
Okay. So when you find those numbers, you can write these binomial pairs. X plus 3, X plus 6. Does that at all look familiar to you?
Yeah.
It's okay if it doesn't. Like I'm not. This isn't like I'm gonna come down on you or anything like that. I just try to know what we're starting with, basically.
Okay.
But you've seen this before now, maybe.
Yeah, definitely.
Okay. So now we're gonna look at the lower left. The lower left is x squared plus 5x plus 6. So can you tell me two numbers that multiply to 6?
2 and 3.
2 and 3. Good. Yeah. So I like to write them in order. There's a reason for that, but 1 and 6, 2 and 3. Do any of these add up to positive 5?
2 and 3.
2 and 3. So your binomial pairs are x plus 2, x plus 3. All right. Now we're going to look at the top right. I want you to try this one on your own. You're looking for two numbers that multiply to 4, but add up to 4. I'd recommend writing
And
the 4 off to the right.
2 and 2, obviously.
You got it. All right. Now, just as soon as you got it, you think, okay, I know this stuff. You get something totally different.
Yeah.
All right. So this is called difference of squares. Have you heard that before?
I don't think so. Or if I did, I don't remember.
Yeah, that's fair. What's different about this compared to the like x squared plus 4x plus 4?
I mean,
Or maybe what's the same? You can always start with what's the same.
we have x 2, but I mean, it's just now subtracting, and the number it's subtracting doesn't have an x.
No, you said really well. X squared and x squared. They both have an x squared. The thing I was also looking for is, see how there's a plus 4x, there's a middle term here. There's no middle term here. Okay, so two terms. And then the other thing you said, which is very important, is there's a difference. There's a subtraction. Okay. Now I'm going to give you the answer to the factoring. What is true about 6 and minus 6? What do they add up to?
0.
Yeah. So it's actually kind of like the previous one in a lot of ways, but it's called difference of squares. If we have time, we'll do more of these. All right. Okay, so here's what we've done. We have factored all of this. Okay. So here's what I'm going to do. I'm going to rewrite. Sorry for moving all this around. I'm going to, instead of the x squared plus 9x plus 18, that was x plus 3, x plus 6. Instead of the x squared plus 5x plus 6, you said x plus 2, x plus 3. Instead of the x squared plus 4x plus 4, you said x plus 2, x plus 2. Instead of x squared minus 36, you said x minus 6, x plus 6. Do you agree with how we've rewritten number 5?
Yeah.
So you did all of that, like you did all the individual pieces here. So now what's left is to cancel. So if it's in the top and the bottom, say there's an x plus 3 and an x plus 3.
Yeah, it's got x plus 2 over x minus 6.
Yeah, you got it. How come you're able to do that so fast? That's really good. You saw that, like you saw the cancellations before I could even write them down. That's really good.
I mean, I remember doing that in class, but I just don't remember the rest.
All right. Well, you're in luck. Number 7 is like number 5, so we're going to do another one.
Okay.
All right. This one's a little bit harder. Like we We unfortunately, it's just like the way math is, like as soon as you think you got it, you get a little wrinkle, little wart that's a little different. And it's
Yeah.
like, so let's look at a squared plus 2a minus 15. So the big difference about this problem is that it's negative 15 now, negative 15. So you're looking for two numbers that multiply to negative 15, but add to positive 2. The only way to get to negative 15 is to have both a positive and a negative number. For example, negative 1 and 15. What do those add to, though?
14.
14, not 2. But if I switch the signs, instead of them adding to a positive, they just now add to a negative. Okay, so that didn't help. But one is positive, one is negative. Do any of these work? Do any of these add to positive 2?
Yeah, negative 3 and 5.
So we get a minus 3, a plus 5. Okay, so hooray, we've done the first one, right?
Uh-huh.
I'm gonna have you try the second one here. I'm gonna try and leave this up so you can see it. A squared plus 3a minus 18. I want you to tell me the two numbers that multiply to negative 18, but now add to positive 3. One positive and one negative.
6.
And
Negative 3.
good.
Yeah. That's
So the order
a
doesn't matter.
squared.
You can put it as a minus 3, a plus 6, or a plus 6, a minus 3. The order doesn't matter. It's not squared though once you put it in parentheses.
Yeah.
The squared comes from when you FOIL it, going backwards, you get the square. Any questions on that?
No.
Okay. Let's go to the bottom left. So the bottom left is yet another kind of like subcase or subcategory type of this factoring. You're looking for two numbers that multiply to 9, but add to negative 6 now. That operator goes with it. So you might think 1 and 9, 3 and 3. And yes, it's true that these all multiply to 9, but they don't add to a negative number. So what do you do? Well, is there any other way to get a positive? Yes, if they're both negative or they're both positive, you get back to a positive. So now do any of these add up to negative 6?
No.
Negative 1 plus negative 9 is negative 10. Negative 3 plus negative 3 is negative 6. Notice when they're the two positives, you get a positive, two negatives, you get the negative out of it. So what does this do?
Why would negative 3 equal negative 6? I thought 2 negatives equal positive.
When they multiply, they get a positive.
Multiply.
So this is like the multiplication column. This is the sum or addition column. So what should I write in parentheses over here? These obviously work. What goes in parentheses? Let's go back and look. In the previous problem, you told me it was minus 3 and 6.
Negative 3, a negative 3, a minus 3. Yeah.
Good. Now what's the other one?
A plus 6. Wait. A minus.
You have a minus 3 though. You took care of that first one. The first minus 3 is this first minus 3. The second one has to
be a minus 3 again.
Yes. Very good. All right. Almost there here. Okay. You're looking for two numbers that multiply to 30, but they have to add to positive 11.
Oh, 6 and 5.
6 and 5. A plus 5, a plus 6. Okay, great. All right, so I'm just re-snipping in number 7. And then now we're gonna rewrite everything. So the first one was a plus 5, a minus 3. That's the top left one. A minus 3, a minus 3. That's the bottom left one. This other one was a plus 6, a minus 3. That's the top right. Bottom was a plus 5, a plus 6. What does this reduce to?
I mean, we can cancel a plus 5 out of both the top right and bottom left, or right.
Yep, good.
And the plus 6 is on the right.
Good.
And the minus 3. Wait, yeah, a minus 3. All 3 of them, or 4.
So in this case, there's actually a 1 and a 1 that's left over. They're just not written.
The 1 over, yeah, okay.
Just becomes 1. All right. Hey, great job today. Is your mom available for some feedback?
Hey, Ma.